Bonsoir à tous. Donc aujourd'hui, we corrige Pure Maths Paper 11, May-June 2021. Donc let's have a look at the first question. Ok. Donc pour la première question, the equation of a curve is such that dy by dx is equal to this. And it is given that a curve passes through the point 12, 4. And you're required to find the equation of the curve. Okay, so from dy by dx, comment you get the equation of the curve? It's simple. We need to integrate. So let's integrate dy by dx to get the equation. So I will write equation of the curve will be integral of dy is equal to integral of 3 over x to the power of 4 plus 32x cubed dx. Donc, quand on integrate dy, I will have y is equal to, so integral of 3 over x to the power of 4. Donc, comment on peut intégrer ça? 3 over x to the power of 4 is same as 3x to the power of minus 4. Donc, quand on integrate, qui me fait, I add 1 to the power and divide by the new power. Donc, les bouvines, 3x to the power of 3 minus 3 divided by minus 3 plus 32x to the power of 4 over 4 plus c. Okay, this integration constant is very important. So you should not omit this constant of integration. Now we will simplify. So I will have y is equal to minus 1 over x to the power of 3. Okay, parce que x to the power of minus 3, quand nous rewrite, leaving 1 upon x to the power of 3 plus, donc 32 sur 4 fait 8, x to the power of 4 plus c. Donc maintenant, we need to find the value of c. Comment on fait to find the value of c? We make use of the coordinate that is given in the question. Donc we can say that at the point half 4, we replace x is equal to half and y is equal to 4. Then we can find the value of c. So 4 is equal to minus 1 upon half to the power of 3 plus x into half to the power of 4 plus c. 4 is equal to minus 15 upon 2 plus c. And finally, c is equal to 23 over 2. Donc, la réponse finale est calée comme ça. Therefore, the equation of the curve is y is equal to minus 1 upon x to the power of 3 plus 8x to the power of 4 plus 23 over 2. Yes. And this is the answer for the first question. Ok, donc là, pour sa question, je peux gagner 2 points in doing this, in integrating correctly, 1 point for substituting in the equation you have obtained above, and 1 point for your final answer. All right. Now let's move on to the second question. Question number 2. So for question number 2, it says that the sum of the first 20 terms of an arithmetic progression is 405, and the sum of the first 40 terms is 1410. You have to find the 60th term of the progression. Donc, pour cette question-là, nous proceed step by step, bout par bout, d'après question 1, d'après information qui est donnée dans question. Donc, first piece of information qui est donnée, c'est que the first 20 term of an arithmetic progression is 405. C'est-à-dire que S20 est égal à 405. Maintenant, remember que dans la liste de formules, the sum of the first n terms of an AP is equal to n divided by 2 into 2a plus n minus 1 times d, where n is the number of terms, a is the first term, and d is the common difference. Donc ici, nous observons cette formule-là pour nous get the sum of the first 20 terms. Donc, instead of S20, we will write this formula. Donc now, since we compare S20 with Sn, you can see that n is equal to 20. Donc, plus n in the formula, you will write 20. So 20 divided by 2 into 2a plus, donc n minus 1, 20 minus 1, which is 19d, is equal to 405. You can simplify to get 10 into 2a plus 19d is equal to 405. Okay, donc ça c'est première équation. Let's continue the question. And the sum of the first 40 terms, li 410. Donc similairement, S of 40 li 1410. Donc vous êtes remplace dans l'équation là, pareil. Donc plus n is equal to 20. Now n is equal to 40. So 40 divided by 2 into 2a plus n minus 1, so 40 minus 1, which is 39d, is equal to 1410. Donc, quand je simplifie, it will be 20 into 2a plus 39d is equal to 1410. And this is the second equation. So now you have two equations with two unknowns that are the first term and the common difference. You can solve simultaneously to find the value of A and D. Et puis, par la suite, c'est qu'à find the 60th term. Donc, let's find the value of A and D. Donc, vous êtes conservé deux méthodes ici pour solve simultaneously. Either substitution method or elimination method. Okay, you need to choose which one you will use wisely parce que les faciles, c'est de faire bonne faute. Donc, par exemple, ici, moi, m'observe elimination method. So, with equation number 1, we utilise, equation number 1, we utilise hypothesis. Donc, nous gagnons 2a plus 19d is equal to 40.5. Donc, I call this equation 3. And avec équation 2, multiplié par 20. So equation number 2 divided by 20, I will have 2a plus 39d is equal to, donc 1410 divisé par 20, which is 70.5. And I call this equation number 4. So using the elimination method, okay, as you can see, je vais tout step by step. Je vais pas miss bonne information qui est important. Les bons qui se présentent, je travaille bien. Donc, je prends équation 4 minus equation 3. So equation number 4 minus equation number 3 Donc, 2a minus 2a is 0. 39d minus 19d is 20d. Et 70.5 retiré 40.5 comma 30. And therefore, d is equal to 30 divided by 20 égale à 1.5. Okay, so now I need to find the value of a. Okay, I can replace the value of t in any equation 1, 2, 3, or 4. So, for example, here I will choose to replace it in equation 3. So I'll say from equation 3, I have that 2a will be equal to 40.5 minus 19d. A is equal to 40.5 minus 19d divided by 2. So là, on remplace the value of d, which is equal to 1.5 in this. Donc 40.5 retirer 19 fois 1.5 divisé par 2. Et mon gain est égal à 6. Yes. Donc maintenant, we need to find the 60th term of the progression. To find the 60th term of the progression, we have to make use of this formula. So you know that Tn, the nth term of an EP, is given by Tn is equal to A plus n minus 1 times t. Therefore, T60 will be equal to A plus 60 minus 1, which is 59 times t. Nous fait trouver que the value of A is 6, the value of D is 1.5. Donc, nous remplace li là-dedans. Donc, 6 plus 59 times 1.5 et il vous donne moins 94.5. So this is the answer for this question. Donc, je vais écrire que the 60th term, sorry, yes, que le 60th term is equal to 94.5. Okay? Donc, for this question, good to get point, c'est the first mark is given here for finding the first equation. Deuxième point ici, pour trouver deuxième equation. Encore un point de gagner pour solve for A and D by substitution. One mark for correctly substituting the value of A and D and using the correct formula for T60. Donc here, and here for the correct answer. Okay, donc this is for question 2. Maintenant, nous avons question 3. Donc, question 3, part A. Find the first free term in the expansion of 3 minus 2x to the power of 5 in ascending powers of x. Donc ici, là, directement, je dois refer to your list of formula given to you for the exam for binomial expansion. Okay? Donc here, if I make this a binomial expansion, it will 3 minus 2x to the power of 5 will be equal to 3 to the power of 5 plus nc1, so 5c1 times 3 to the power of 4 into minus 2x plus 5c2 into 3 to the power of 3 into minus 2x to the power of 2, and so on. Okay, we need the first three terms. So we have the first term, second term, and third term here. All right? Donc maintenant, qui nous fait du simplifier. Donc 3 to the power of 5 is 243 plus 5c1. Donc 5c1 is 5. 3 to the power of 4 is 81 times minus 2x plus 5c2 is 10. 3 to the power of 3 is 27. And minus 2x to the squared is 4x squared. OK, donc we simplify. Donc 243 plus 5 fois 80 fois moins 2 will give me minus 810x, don't forget, plus, donc 10 fois 27 fois 4, 1080x to the power of 2. And this is the answer in ascending powers of x. Okay, remember. So we start with x squared. Good. Now let's move on to the next part. Part B. Hence find the coefficient of x squared in the expansion of 4 plus x to the squared into 3 minus 2x to the power of 5. Donc pour ici, là, quelque chose à noter que vous n'êtes pas besoin d'expander complètement parce que nous avons que coefficients of x squared. Donc you don't have to go and expand the second term completely. Ce qui est dans là-haut, là, ce qui est fait qu'expand là-haut, là, enough because you have up to the term in x squared. So you stop right there. You don't have to expand further. So how to proceed? We have 4 plus x to the squared into 3 minus 2x power 5. Donc ça peut égal à... Donc remember que a plus b to the squared is equal to a squared plus 2ab plus b squared. Donc ce concept-là, il peut apply for the first one. So you have 4 plus x whole squared. And you make use of a squared plus 2ab plus b squared. So we will have 4 squared plus 2 times 4 times x plus x squared into this, nous prenons réponse directement pour port A. Donc, pour port A, nous avons 243 plus, désolé, moins 810x plus 1080x squared, etc. Okay, we don't need a term greater than x squared because we are finding the coefficient of x squared. Donc, ça peut donner nous, let's simplify the first part. Donc, 4 squared is 16 plus 2 times 4, 8x plus x squared into 243 moins 810x plus 1080x squared and so on. We need to find the coefficient of x squared. Donc, qui se comprend par coefficient of x squared? Coefficient of x squared means the value that is found in front of x squared in the expansion of this. Donc, ça veut dire qu'il n'est pas include, quand vous pouvez créer cette réponse, quand je vous donne cette réponse, you just have to give a numerical value. You don't have to include x squared. Donc, from this expansion, qui peut donner nous x squared? Donc, 16 times 1080x squared will give me a term in x squared. Donc, 16 fois 1080 plus a term in x multiplied by a term in x will give me a term in x squared. Donc, plus 8x multiplied by moins 810x, pour de moins un terme in x squared, et x squared multiplied by 243 pour de moins, donc plus 1 x squared multiplied by 243, will also give me a term in x squared. Donc, me simplifier. When I simplify, I should get 11,043 as the coefficient of x squared. Okay. Donc, for part A, que ça c'est bien point, you get correct marks for each term of your expansion. Donc, vous gagnez un point. Vous gagnez sa first correct term là, un point. For the second correct term, which is moins 810x, et for the third correct term, which is 1080x. And for part B, you will get one more correct expansion of 4 plus x whole squared, donc this, one more for this. You get one mark for finding qui one term qui peut donner x squared et one mark for the correct answer. Ok, pour question numéro 4, donc you're given a graph. So the diagram shows part of the graph of y is equal to a tan of x minus b plus c. Given that b is greater than or equal to 0 and less than, is greater than 0 and less than pi, state the values of the constants a, b, and c. All right. Donc, cette question-là est une question de transformation. So, here, if you want to know Keyboard transformation, so you can consider a transformation from y is equal to tan of x to y is equal to a tan of x minus b plus c. All right. Donc, if I want to find the transformations, so from y is equal to tan of x to y is equal to this, I can find the transformations. Donc, on peut dire que y minus c is equal to a tan of x minus b, and y minus c divided by a is equal to tan of x minus b. So let me list down the three transformations that we have. So first transformation that we have, say this one. Okay? So this transformation is a one-way stretch. Parallel to the y-axis with scale factor a. A second transformation that is this one. Donc, ça qui lui peut représenter, it represents a translation of c units in the direction of the y-axis. And the last transformation that I have is this one here. So number 3, I have again a translation of b units in the direction of the x-axis. Okay, donc comment we find the values of a, b, and c? Let's first compare the given graph qui peut représenter y is equal to a tan of, okay, let me zoom in. Yeah, a tan of x minus b plus c. So if I want to find the value of c, which is the easiest, c represent a translation of c units in the direction of the y-axis. Okay. Donc, si we consider this graph over here, I can see that the graph starts from this point. Okay, il pas start from the x-axis, mais plutôt from here. Donc, c'est la ligne qui me joue là. So, instead of starting on x is equal, on the line x is equal to 0, it starts on the line x is equal to 1. Therefore, the value of c is 1 parce qu'il peut translate by 1 on the x-axis. So c is equal to 1. Next, Kinuka find the translation of the units in the direction of the x-axis. So we know that traditionally the graph for tan of x is start at 0, 0, could 1/4 pi it's 1, and at pi by 2 it has an asymptote where it goes up to infinity. Donc graphe là comme ça, à peu près. Okay. But instead of starting at 0, il peut start ici, at 1/4 pi. Okay, quand est dans la ligne. Kotlin translate up là, where y is equal to 1. So instead of starting at 0, 0, il peut start at 0, 1. So as you can see, there is a shift of pi by 4 in the direction of the x-axis. Donc, b is equal to 1/4 pi by 4. All right. So, numeracy trouve the value of b. Numeracy trouve the value of c. Now, how can we find the value of b? Donc, nous remplace toujours l'unité qui forme the equation in. So, y is equal to a tan of x minus pi by 4 plus 1. Donc, to find the value of a, we can choose any coordinate on the graph. Okay, so let's choose a coordinate which is easy to replace. So this one. So we have 0, minus 1. Let's replace the coordinate 0, minus 1 in this equation to find the value of b. So minus 1 is equal to a tan of 0 minus pi by 4 is minus pi by 4 plus 1. So minus 2 is equal to a times minus 1. Therefore, the value of a is equal to 2. So a is equal to 2, b is equal to 1/4 pi, and c is equal to 1. And you have your answer. So for this question, you get 1 point for finding the value of c, 1 point for finding the value of b, and 1 point for correctly finding the value of a. Okay? This question is new. Il est assez nouveau parce que topic transformation. All right. Donc maintenant, ne bougez, on va faire question number 5. So number 5, the 5th, 6th, and 7th term of AGB are 8k minus 12 and 2k respectively. Given that k is negative, find the sum of infinity to the sum to infinity of the progression. Okay, so we have 3 consecutive terms of the progression of AGP. Donc remember que en général, AGP is represented by AL squared, AL cubed, AL power 4, and so on. Okay, Donc, each time, as you can see, in a common ratio to R. We are multiplying each time by R. So if you have three consecutive terms, si tu envie find the common ratio, you can use the second term upon the first term, sorry, the second term. The second term over the first term should be equal to the third term upon the second term. Okay, and both of them should give us the value of O. Donc, similarly, this applies for three consecutive terms. So here we are given three consecutive terms. Let's make use of this to find the value of t. So the fifth term, which is minus 12, divided by the sixth term divided by the fifth term, minus 12 divided by 8k should be equal to 2k divided by minus 12. Donc, I cross-multiply, donc moins 12 fois moins 12, 144, is equal to 2k times 8k. Donc, 2 times 8, 16, k squared is equal to 144. K squared is equal to 144 divided by 16, which is 9. And k is plus or minus square root of 9, which is plus or minus 3. Maintenant, on note que dans la question, t is negative. So we will reject the value for k that is positive. So since k is negative, k is equal to minus 3. Maintenant, what is the formula for the sum to infinity? Sum to infinity is equal to a upon 1 minus r. Mais dans la question, we are not given a, the first term, and r, the common ratio. We need to find a and r. Okay, let's start by finding the common ratio. Donc again, we will make use of this. The second term divided by the first term give us the common ratio. C'est-à-dire que term qui après, divided by the term before it, will give us the common ratio. So I can make use of this to find the common ratio of R is equal to, I can say que, yeah, the sixth term divided by the fifth term, donc moins 12 divisé par 8k, and we know that k is minus 3, will give us R, donc this will give us half. Maintenant, to find the first term, we know that the sixth term is minus 12. T6 is equal to minus 12. C'est-à-dire que A power 5 is equal to minus 12. On lui fait trouver que half, donc A times half power 5 is minus 12. A is equal to minus 12 divided by half to the power of 5. Donc A is equal to minus 385. The true value of R, the true value of A, we can find the sum to infinity. So the sum to infinity, which is equal to A over 1 minus R, is moins 384 divisé par 1 minus R. Donc, à la fin, you should get moins 768 for the sum to infinity. Okay? So this is how you should tackle this question. Donc, pour cette question, que de 3 points. So the first point that you score is here. When you form this equation, donc ce point forme sa équation-là, you get also 1 mark for stating que the correct value of k, que k est a une seule value, et infini dans cette question que k is negative. 1 point for finding the value of a and r and replacing it correctly in the sum to infinity. Et finalement, one last mark for the correct answer. Okay. For question number 6 now, the equation of a curve is this, y is equal to this, where k is a constant, and you are given a line, this, which is a tangent to the curve. Okay, you're asked to find the value of k. So let's write down the two equations. Equation of the curve, y is equal to 2k minus 3 squared minus kx minus k minus 2. Equation number 1. The equation number 9 is y is equal to 3x minus 2. Equation number 2. So here, let's eliminate y. First step, eliminate y to get 2k minus 3x minus kx minus k minus 2 is equal to 3x minus 4. You can simplify it on 2k minus 3x squared minus k plus 3x minus k minus 6 is equal to 0. Next, you know that this line is a tangent to the curve. So when a line is tangent to the curve, you know that the discriminant b squared minus 4ac is equal to 0. So line is a tangent to the curve, which implies that the discriminant is equal to 0. b squared minus 4ac is equal to 0. So from this is b, sorry. This is A, this is B, and this part is C. Donc, vous êtes remplacé. Minus K plus 3 whole squared minus 4A times minus 1 times K minus 6 is equal to 0. Donc, minus 1 to the square is plus 1, K plus 3 to the square. Minus 4 times minus 1 is plus 4 into 2k minus 3 into k minus 6 is equal to 0. Okay, from here you can simplify. So k squared plus 6k plus 9 plus 8k minus 12 into k minus 6 is equal to 0. K squared plus 6k plus 9 plus, okay, let's expand now. 8k squared minus 48k minus 12k plus 72 is equal to 0. 9k squared, okay, so k squared plus 8k, 9k squared minus 54k plus 81 is equal to 0. We can now divide by 9 as a common factor. So k squared minus 6k plus 9 is equal to 0. From here, we can factorize this quadratic equation to get k minus 3 whole squared is equal to 0. So either k is equal to 3 or k is equal to 3. Okay, it's completely normal to have the same value of k because the line is a tangent to the curve. Donc, each time quand je trouve line is a tangent to the curve, you should obviously have two same values. So real and equal roots. So therefore, k is equal to 3. Okay. So for this question, good is it score 1? You get 1 mark for eliminating y, 1 mark for simplifying, 1 mark for correctly stating que b squared minus 4 ici is equal to 0 et je remplace correctement. 1 mark for finding the quadratic equation. So either this or this one, 1 mark for this. And finally, 1 mark for the correct answer, which is k is equal to 3. Good. So let's have a look at the next question. Question number 7. Okay. So question number 7, you have to prove the identity. That you have to prove the left-hand side is equal to the right-hand side. So for this question, you can choose to start either with the left-hand side or with the right-hand side. Let me choose the left-hand side. So let's start by the left-hand side. So left-hand side is equivalent to 1 minus 2 sine squared theta divided by 1 minus sine squared theta. Okay. So 1 minus 2 sine squared theta, we can remember to from the double angle formula, cos 2 theta is equal to 1 minus 2 sine squared theta, which is also equal to cos squared theta minus sine squared theta. Okay, so instead of writing cos 2 theta, because elsewhere, the identity we have to prove, we don't have a double angle for tan. So we will not make use of cos 2 theta. Instead, we can make use of this. So this can be rewritten as cos squared theta minus sine squared theta over root 1 minus sine squared. So again, remember that cos squared theta plus sine squared theta is equal to 1. So sine squared theta should be equal to 1 minus cos squared theta. So we'll make use of this here. Minus 1 minus cos squared theta. Let's simplify. From cos squared theta minus sine squared theta divided by 1 minus 1. Okay, 1 minus 1 is 0. And minus cos squared is cos squared theta. So cos squared theta divided by cos squared theta is 1 minus sine squared theta upon cos squared theta. Okay, remember good. Tan theta is sine theta upon cos theta. So sine squared theta upon cos squared theta should yield tan squared theta, which is what is on the right hand side, which is equivalent to the right hand side, hence proved. All right. So you get 1 mark for correctly manipulating through the trigonometric identities, and 1 mark for correctly showing that the left-hand side is equal to the right-hand side. So now let's move on to part B, which asks us to solve this part, which qui nous fait trouver dans, nous fait prove in part A is equal to 2 tan to the power of 4. For theta trouve entre 0 degré et 180 degrés. Okay, so let's start by rewriting the given equation. All right. So we know from part A to 1 minus 2 sine squared theta divided by 1 minus sine squared theta is same as 1 minus tan squared theta, which is equal to 2 tan to the power 4 theta. Donc, nous, on va tout d'un seul côté. Donc, 2 tan power 4 theta plus tan squared theta minus 1 is equal to 0. So here you have an equation. This is an equation, a disguised quadratic equation. Okay. So we can factorize this disguised equation. So let's factorize it. 2 tan squared theta minus 1 into tan squared theta plus 1 is equal to 0. Let's solve. So either tan squared theta is equal to half, or tan squared theta is equal to minus 1. Okay, so tan theta here is either plus or minus square root of half. And here you have square root of negative 1, which is a complex number, so we will reject this one. So let's continue with tan theta is equal to plus or minus half. So here the basic angle or the key angle will be tan inverse of positive square root of half, tan inverse, which is equal to 35.264 degrees. Okay, make sure that your calculator is in degree mode, because here the range is given in degrees, donc la réponse should be in degrees. Yeah. So let's consider when tan is equal to positive square root of 4. So let's draw the quadrants. Donc, as you know, add sugar to coffee. Donc, in the first quadrant, all ratios are positive, so therefore tan should be positive in the first one. In the second one, no. In the third quadrant, yes, tan is positive in the first and third quadrant. Okay, donc we will consider only the first value of tan. Sorry. Yeah, only the first value of tan in the first quadrant, parce que après, here in the third quadrant, tan is greater, the value of tan theta would be greater than 180 degrees, the value of theta. Donc, therefore, theta is only equal to 35.264 degrees for the first quadrant. And now let's consider the case when tan theta is equal to negative square root of half. So again, donc here tan will be negative in the second and fourth quadrant. Donc we'll consider this and this value. Mais puisque the range is on 0 à 180 degrees, we will consider the value of tan only in the second quadrant. So therefore theta is equal to 180 degrees minus 35.264 degrees, which is equal to 144.735 degrees. Okay, so your final answer should be given to 1 dp for any angle in degrees. So therefore, theta is equal to 35.3 degrees and 144.7 degrees to 1 decimal place. All right. So for this question, you score marks are given for here for substituting this for 1 minus tan squared, for getting the correct answer for tan theta, and finally to obtain the correct values of theta to 1 decimal place. Okay, so now let's move on to question number 8. Okay, so you're given a diagram. The diagram shows a symmetrical metal plate. The plate is made by removing two identical pieces from a circular disc with center C. The boundary of the plate consists of two arcs, PS and QR of an original circle. So basically, this is a circle. The radius of the circle with center C is 4 centimeters. So basically, this distance is 4 centimeters. And PQ, the distance PQ, and S is 4 centimeters as well. So we need to show that angle PCS, so this angle, that angle PCS, okay, somewhere here. This angle is 235, okay? So we can, okay, yeah, so we can do this by dropping perpendicular here, right? So we know that PC should be equal to 4 centimeters as well. Yeah, because it is a radius. It starts from the center of the circle and ends on the circumference of the circle. So this PC and CS should be 4 centimeters as well. Let's call this point M1, midpoint of PQM1, and midpoint of SRM2. So therefore, PM1 is equal to 2 centimeters because it is halfway between PQ, so 2 centimeters. And we have a right angle triangle. So we can find angle PCM1. And angle PCM1 will be equal to angle SCM2. And this whole angle is pi radian. So since we know when we find PCM1, this angle here, we already know the second angle here. Therefore, using the property that the angle here is 180 degrees, that is pi radian, we can find PCS. Okay, so let's find angle PCM1. So first, yeah, we will say that let M1 and M2 be the midpoint of PQ and SR respectively. Okay, we're just labeling the diagram that PM1 is 2 centimeters. So we can use sine of PCM1 is equal to 2, this side, upon 4, the hypotenuse. So sine of PCM1 is equal to angle PCM1 to 4. This implies that PCM1 is equal to sine inverse of 4, which is pi by 6. And therefore, angle PCS would be equal to pi radian minus twice this angle, 2 times pi by 6. Why 2 times? Because this angle PCM1 is equal to SCM2. So that is why we have used twice pi by 6. And finally, the answer should be 2/3 pi radians. Okay, so you get 2 marks for doing this, 1 mark for finding the sign of PCM1, and then 1 mark for finding the correct answer. Right. So now, next part B, you're asked to find the exact perimeter of the plate. Okay. So to find the exact perimeter of plate, we need to find the length of arc PS, which is also equal to the length of arc QR, and this length of arc PQ, which is also half the circumference of a circle, because it's a semicircle, which is also equal to SO. We will have the same value. So first, let's find the length of arc PS. So length of arc PS, yes. So you know that length of arc is given by S is equal to R theta. So we know that the radius is 4 centimeters, and this angle, the angle which lies between, which is PCS, is 2/3 pi radians. The length of arc PS is equal to 8/3 pi radians. Okay, since it's in centimeters, let's write centimeters. Now, to find the length of arc PQ, the semicircle, the length of the semicircle PQ, since we know that it's a semicircle, the circumference of a circle is 2 pi r. So the circumference of a semicircle would be half of that. And we know already that the diameter is 4 centimeters, so the radius would be 2 centimeters. All right. So length of arc PQ would be half of 2 pi r, 2 pi r. Since we are given the diameters, I will write d by 2. So half times 2 pi r will give me pi into the d, which is 4/2, 2 pi centimeters. So therefore, the exact perimeter would be the perimeter of the plate. It will be PS plus PQ plus SB plus QP. So that will be 8/3 pi plus 2 pi plus 2 pi plus 8/3 pi. So when we simplify it, we should get 28/3 pi centimeters. All right. So leave your answer in terms of pi because you are asked to find the exact perimeter of the plate. All right. So here you're given 1 mark for finding the length of arc PS, 1 mark for finding the circumference of the semicircle, and 1 mark for finding the correct answer for the perimeter of the plate. Let's move on to the next part, which is to find, show that the area of the plate is this. Okay, again, it's in exact form. Okay, so let's analyze the drawing. Okay, so we need to find the area of this shape. over here. How can we find this? So we know that initially it was a circle. So we can find the area of the circle. Next, you have two semicircles which are inscribed in it. So we can also find the area of one semicircle and then multiply by 2 and remove it from the area of the whole large circle. But to remember that there will be always this small part here, which we will have to remove from the area. So from this, we can find the area of a sector first, area of the whole sector, minus the area of this small triangle here to find this area. And when we find the area of this small segment here, we can remove it from the area of the whole circle and the area of the semicircle. Right? So let's find it. So first, we'll find the area of the big circle. So area of the large circle is pi r squared, and we know that r is 4, so pi times 4 to the square, so 16 pi centimeters squared. Next, we find the area of one semicircle. So area of semicircle, let's say semicircle PQ would be half of pi r squared. So half of pi r squared. So the diameter of the semicircle is 4 centimeters, but the radius of the semicircle would be 2 centimeters. So therefore, we have half times pi times 4, which is 2 pi centimeters squared. All right. Now for the segment, let's say the segment PQ. Area of segment PQ, as I have explained, of small segment PQ will be the area of sector PCQ minus the area of triangle PCQ. So the area of the sector PCQ will be half r squared theta, which is 2 times pi by 6. Okay, it's twice this angle, it's twice the angle that we found for the right angle triangle. Okay, twice this angle, so 2 times pi by 6. Half r squared, which is 4, right? Okay, minus the area of the triangle. So the triangle has side of length 4 centimeters each. So let's make use of the formula half AB sine C. So half times 4 times 4 times sine of the included angle, which is again 2 times pi by 6. And when we simplify, we have 8 pi by 3 minus 4 root 3. So therefore, the area of the plate will be the area of the large circle, 16 pi, minus 2 times the area of one semicircle, but since we have two semicircles, minus 2 times pi, minus 2 times the area of the small segment. So minus 2 times 8 pi by 3 minus 4 root 3. This leads us to 16 pi minus 4 pi minus 16 pi by 3 plus 8 square root of 3. When we simplify, we will get 20 pi by 3 plus 8 square root of 3 centimeters square. So hence shown, okay, we have what was required from the question here. Okay? So now where do you score those 5 marks? You get 1 mark for finding the area of the semicircle. You get 2 marks for finding the area of sector minus the area of the triangle. And you get 1 mark for correctly subtracting those from the area of the lower circle, and 1 mark for showing the correct answer. Good? Okay, so for question 9, we are given 2 functions. Functions f and g are defined as follows. So f of x is equal to x minus 2 whole squared minus 4 for this domain. So x is greater than or equal to 2. And g of x is equal to ax plus 2 for x belonging to the values, to the set of real values, where a is a constant. So for the first part, you are asked to find the range of f. It's simple. So you have to replace the value of x is equal to 2 in f of x. So f of 2 is equal to 2 minus 2 whole squared minus 4, which is equal to minus 4. So therefore, the range of f is f of x is greater than or equal to 4. Okay, you should not write y here. You should write f of x is greater than or equal to 4. And you get 1 mark for this. Next part, you are required to find f inverse of x. All right, so let's find f inverse of x. First of all, let's say let y is equal to f of x. Y is equal to x minus 2 whole squared minus 4. X minus 2 whole squared is equal to y plus 4. X minus 2 is equal to plus or minus square root of y plus 4. And x is equal to 2 plus or minus square root of y plus 4. Okay, here we need to choose which sign will correspond for the inverse function. Okay. So for the choice of sign here, choice of sign. Let's choose a point that for x that is greater than or equal to 2. Let's say for x is equal to 3. Okay, we should never use the turning point while choosing the sign. For example, here we have the minimum point to be equal to 2 minus 4. So, for example, here we cannot use x is equal to 2 since this is the turning point. So let me use x is equal to 3. So when I replace x is equal to 3 in this equation, my y coordinate will be minus 3. So using this for the choice of sign, I replace this in here. So 3 is equal to 2 plus or minus square root of minus 3 plus 4. 3 is equal to 2 plus or minus 4 minus 3 is 1, square root of 1 is 1. So 2 plus 1 will give me 3. So therefore, x is equal to 2 plus square root of y plus 4. So my final answer for f inverse of x is equal to 2 plus square root of x plus 4. Okay, I changed the y to x since I have f of x. And this is the answer. So here you get 1 mark for finding the inverse and 1 mark for correctly choosing the sign and giving the correct answer here. about C now. Given that A is equal to minus 5 upon 3, solve the equation f of x is equal to g. Okay, so f of x is equal to g of x. F of x is x minus 2 squared minus 4. And g of x is minus, is 8x plus 2, so minus 5 over 3x plus 2. Let's expand. So x squared minus 4x plus 4 minus 4 is equal to minus 5 over 3x plus 2. This and this cancels out. We simplify. So we have x squared minus 7 upon 3x minus 2 is equal to 0. We can multiply by 3. So we have 3x squared minus 7x minus 6 is equal to 0. And now we have a quadratic equation next, so we can factorize. So 3x plus 2 into, x minus 3 gives us 0. So either x is equal to minus 2/3 or x is equal to 3. So we will reject this value. Why? Because initially f of x was greater than, x is greater than or equal to 2 for f of x. So therefore, x is equal to 3 only. So for this question, you score 1 mark for finding the correct quadratic equation here, and 1 mark for giving only one value of x. Okay, so moving on to part D. Given instead that g of f inverse of 12 is equal to 62, find the possible values of it. All right, so let's first do it step by step. Let's first do f inverse of 12. So that would be 2 plus square root of 12. Okay, we just found the inverse from part B. So we replace the value of 12 in our answer for part B. So 2 plus square root of 12 plus 4 is equal to 6. So this is f inverse of 12. Now let's find g of f inverse of 12. So g of f inverse of 12 is equal to g of 6, because f inverse of 12 is 6. So that would be 6a plus 12. Next part, g of f inverse of 12. So g of f inverse of 12. So that would be g of 6a plus 2. So we replace the x by 6a plus 2. So that would be a into 6a plus 2 plus 2. All right. So now that we are given that g of f inverse of 12 is 62. So g of f inverse of 12 is equal to 62. That means that a into 6a plus 2 is equal to 62. We can expand and send the 2 on the other side. So that would be 6a squared plus 2a is equal to 60. 6a squared plus 2a minus 60 is equal to 0. We can divide by 2. So 3a squared plus a minus 30 is equal to 0. Here we can factorize. So 3a plus 10 into a minus 3 is equal to 0. And finally, it's either a is equal to minus 10 over 3 or a is equal to 3. Okay, so we have found the values of a. So for this question, you score marks for finding f inverse of 12, 1 mark for correctly finding g of f inverse of 12, 1 mark for correctly finding g of f inverse of 12. And 1 mark for replacing this here and equating it to 62. 1 correct mark for finding the quadratic equation, and 1 mark for finding the values of e. Good. So now let's move on to question number 10. So question number 10, we have the equation of a circle, which is x squared plus y squared is equal to this. First part, we need to find the coordinate of the points A and B where the circle intersects the x-axis. So we know that on the x-axis, y is always equal to 0. So we will replace y is equal to 0 in the equation of the circle. X squared plus 0 to the square minus 4x plus 6 times 0 minus 77 is equal to 0. Let's simplify. So x squared minus 4x minus 77 is equal to 0. We can factorize, so x minus 11 into x plus 7 is equal to 0. So either x is equal to 11 or x is equal to minus 7. So therefore, the coordinates of A and B are so minus 7 and 0, and then 11 and 0. So here you score 1 mark for correctly replacing y is equal to 0 in the equation of the circle, and 1 mark for finding the correct coordinates of A and B. Good. So now let's go for part B. Okay. Part B, it says to find the point of intersection of tangents to the circle at A and B. So for this one, let's draw a diagram. Okay, so I will draw the diagram here because I have space here. So you have a circle. Let's call its center C. And on the x-axis, let's say here, at points A and B, so minus 7, 0, and 11, 0. Yeah. So these form the tangent to the circle. You have two tangents here, one here and one here. And let's say this is the point of the intersection. Let's call it M of the tangent. So I can join the tangent. This should be 90 degrees since it is a tangent to the circle. And here as well, it's 90 degrees. Good. So we have a drawing. We know the coordinates of A. We know the coordinates of B. We need to find the equation of the tangents. That is the tangent at A, the tangent at B. Once we find the coordinates of the once we find the equation of the tangents at A and B, we can solve them simultaneously to find the point of intersection. So first of all, we need to find the coordinates of the center of the circle. So we know that the equation of the circle is x squared plus y squared minus 4x plus 6y minus 677 is equal to 0. Let's complete the square. So x squared minus, okay, let me rewrite it as such. X squared minus 4x plus y squared plus 6y minus 77 squared. Let's complete the square for x. Let's complete the square for y. So I will have x minus 2 to the square minus 4. This is 4x. For y, so plus y plus 3 to the square minus 9 minus 77 is equal to 0. So x minus 2 to the square plus y plus 3 to the square is equal to 77 plus 9 plus 4, which gives me 90. So from this, I can deduce that the center of the circle C is 2 minus 3. This is the coordinate of C. So C is 2 minus 3. All right. So I can find the gradient of AC and the gradient of CB. Let's say this is the normal to the tangents. So I can find these two gradients, and then I can find the gradient of the tangent. Once I find the gradient of the tangent, I use the points A and B to find the equation of the tangents, and then I can solve them simultaneously to find the point of intersection N. So let's first find the gradient of AC, the gradient of, so gradient AC will be equal to y2 minus y1 upon x2 minus x1, so minus 3 over 9, which gives me minus 1/3. Gradient BC, so minus 3 minus 0 upon 2 minus 11, which is minus 3 over minus 9, 1/3. So I have the gradient of AC this and the gradient of BC this. I can find the gradient of the tangent at A. The gradient of tangent at A would be 3. Okay, because m1 times m2 should give me minus 1. So minus 1/3 times m2 is minus 1. So m2 should give me 3. And then similarly, gradient, this is that the product of gradients is equal to minus 1. Yeah. So gradient of tangent at B now would be equal to minus 3. Now I have the gradient of the tangent at A, the gradient of the tangent at B. I can find the equation of the tangent using the points A and B. So let's find the equation of the tangent at A. Equation of tangent at the point A, which is minus 1. So I have 1, 2 minus 1, and x2 minus x1 is equal to the gradient, which is 3 at A. So y is equal to 7, sorry, 3 into x plus 7. Y is equal to 3x plus 21. So this is the first equation, the equation of the tangent at A. Now the equation of the tangent at B. So the coordinates of B are 11 and 0. So y2 minus y1 upon x2 minus x1 is equal to the gradient at B. So y is equal to minus 3 into x minus 7. Okay. So y is equal to minus 3x plus 33. This is our second equation. So we can eliminate y from the first equation and the second equation to solve simultaneously. So eliminate y from 1 and 2. So 3x plus 21 is equal to minus 3x plus 33. 6x is equal to 12. Therefore, x is equal to 2. So I can choose any equation 1 or 2 to replace x and find the value of 1. So let's choose equation 1. So from equation number 1, y is equal to 3x, which is 2, plus 21. So 6 plus 21 is 27. So therefore, the required coordinates coordinates for the point of intersection are 2 and 27. Okay, so now let's move on to the last question, which is question number 11. So the equation of a curve is y is equal to 2 square root of 3x plus 4 minus x. First part, find the equation of the normal to the curve at the point 4, 4, giving your answer in the form y is equal to mx plus c. So in the form of a line. So the tangent to the curve is given by dy by dx. So dy by dx is when we differentiate 2 into 3x plus 4 to the power of 12 minus x, we'll have 2 over 2 times the square root of 3 plus 4 multiplied by 3 minus 1. So when I simplify, I should get donc ça fait 3 over square root of 3 plus 4 minus 1. So now what is the value of the gradient? That is the gradient to the curve of 4, 4. So dy by dx at x is equal to 4. I replace the value of x is equal to 4 in this. So 3 into square root of 3 times 4 plus 4 minus 1. It's equal to minus 1/4. So the gradient of the tangent, the gradient of the tangent of the x is equal to 4 is minus 1/4. So gradient of tangent at the point 4, 4 is equal to 1/4, which implies that the gradient of the normal, the one which is perpendicular to the tangent, at 4, 4 should be equal to 4. Okay, so minus 1 times minus 1/4 times 4 should give me 1. Good. So now that I have the gradient of the normal and I have a point, I can find the equation of the normal. So the equation of normal at 4, 4. So I make use of y minus 4 over x minus 4 is equal to 4. Y minus 4 is equal to 4 into x minus 4. So y minus 4 is equal to 4x minus 16. So therefore, y is equal to 4x minus 12. And this is the equation of the tangent of the normal, at 4, 4. So for this question, here, you score points for correctly, 2 points for correctly differentiating the equation of the curve to get the gradient of the curve. 1 more for correctly finding the tangent of the point, the gradient of the tangent and the gradient of the normal from that. And 1 more for correctly finding the equation of the normal. So next you're asked to find the coordinates of the stationary point. So that's easy. We know that at stationary point, dy by dx is always equal to 0. And we already know dy by dx from the first part. So dy by dx is 3 over square root of 3x plus 4 minus 1. It's equal to 0. So 3 over square root of 3x plus 4 is equal to 1. 3 is equal to square root of 3x plus 4. So we can square both sides. 3x plus 4 is equal to 9. 3x is equal to 5. So x is equal to 5 over 3. And to find the y coordinate, we need to replace in the equation of the curve. So the equation of the curve is 2 square root of 3 into x. So 5 over 3 plus 4 minus 5 over 3. And y should be equal to 13 over 3. So therefore, the coordinates of the stationary point is 5 over 3 and 13 over 3. So here you get 1 mark for equating the dy by dx to 0, 1 mark for finding the correct value of x, and 1 more mark for finding the correct stationary point. But C, determine the nature of the stationary point. So to find the nature of the stationary point, we need to find y by dx squared. And depending whether it's equal to 0, greater than or equal to 0, or less than 0, we can determine whether it's maximum, minimum, or a point of inflection. So dqy by dx would be equal to, we need to differentiate dy by dx. So when I differentiate dy by dx, it's equal to 2 into 3x plus 4 to the power of minus 3 quarter times 3. So it's minus 9 over 2 into 3x plus 4 to the power of 3 quarters. So at the stationary point, at x is equal to 5 over 3, dy by dx squared is equal to minus 9 over 2 into 3 times 5 over 3 plus 4 times to the power of minus 3 quarter. This gives minus 1 upon 6. So minus 1 upon 6 is less than 0. This means that the stationary point is a maximum. So therefore, the stationary point is a maximum point. Okay, so here you get 1 mark for correctly differentiating the dy by dx, and 1 mark for correctly stating that it is a maximum point. And the last part D, find the exact area of the region bounded by the curve, the x-axis, and the lines x is equal to 0 and x is equal to 4. So when you have to find this area, you have to integrate the curve, which means integral of y dx. So we will integrate between the limits from x is equal to 0 to x4 of y. So y is 2 square root of 3x plus 4 minus x dx, which is equal to, so let's integrate this part, 2, 3x to the power of 3x plus 4, which is to the power of 4. So half plus 1 is 3 over 2. We divide by 3 over 2 and we multiply by 3. Minus x squared over 2 from 0 to 4. Simplify, so we have 4 over 9 into 3x plus 4 to the power of 3 over 2 minus half x squared. We integrate from 0 to 4. So first we will replace the value of 4, so 4 over 9 into 3 times 4 into 3 times 4 plus 4. This gives us 16 to the power of 3 over 2 minus half times 4 to the squared, so minus 8 Now we replace the value of x, so minus 4/9 times 3 times 0 plus 4, so 4/9 times 4 to the power of 3/2 minus 0, because half times 0 to the squared gives us 0. So we have, when we type in this in the calculator, it gives us 152/9, which is 16 and 8/9. And this is the exact area, exact value, as you can see, in mixed number, mixed fraction. Here, centimeters or units, units squared. Don't forget to write the units squared. So for this question, you have 1 mark for correctly integrating the curve with the limits from x is equal to 0 to 4. 1 mark for correctly simplifying. 1 mark for correctly plugging in the values of zeros and 4. And 1 mark for correctly getting the answer for the area. Okay, so that's it for today. Thank you.